Hello, my name is Nathan, otherwise known as Old Man Builds. We have the Benefactor here, and we're in the Builder's Workshop. We have some exciting stuff going on today. Ben's rocking it out. Got 300 volts out of what, a 12-volt input, Ben?
Yeah, like about 14 volts. So we got 14.
Volts.
Yeah, and well, we have about 17 volts going into the stereo amp from the power supply, but we can take that down to 8, honestly, and I have, and still lit like 4 of those neon lamps with the Mark 1 coil. It's really extraordinary. I could play the clip in a minute, but I have a small presentation to go over some numbers, some new numbers, and also a small demonstration. So
Absolutely. When you're ready, Ben, go for it.
awesome. So let me play this little clip, the short clip that I uploaded recently, the music-free one. Let's see. So we have... Okay, guys, this is big. This is very, very big. All right? This is a complete and total confirmation of the voltage we're getting. Okay, check this out. Got 210 hertz sine waveform into our Mark 1 coil. Going to the stereo amp board is going to the coil. The coil is going to a 2000 HV cap, 0.15 unifarad. Sorry, that's my bad. I'm a newbie. That's microfarad, not unifarad. I was reading UF. It's actually microfarad.
You put a Tesla coil cap in there.
Yes, I did.
Oh, that's right. Okay. All right. I didn't want to miss that. All right.
Nope. And I also have some interesting updates on the theory behind it as well that I think you're going to be really proud of the theories that I've developed for this setup and how it's working. So, and that is going to a breadboard. All that's just disconnected. Just pay attention to these neons right here. So we turn this up. Check this out. Listen for the hum. Oh. So we have approximately 330 volts coming out of the coil with only about 14 or 15 volts going in. And we're going to demonstrate that tonight, and I'll show you the new numbers in a second once I load the documents.
And you pulled that on your meter as well, right?
Yes. So this actually aligns with what we were seeing on our oscilloscope, which, as you know, oscilloscopes are more accurate in picking up that kind of data. So, I was getting inconsistent numbers with a couple of my multimeters. We'll get into that in a minute. But however, since I adjusted, we are seeing confirmation of the voltage numbers I am getting currently with the oscilloscope numbers, and that all aligns with this, these neons lighting. So everything's starting to fall into place here, and getting an idea of what's going on with the energy and how much usable energy we do have to work with, and how to maximize the efficiency of the system, which is the most important part. Because as I'll get into in a minute, spoiler alert, we're not just resonating the coil with the inductor with the capacitor. We're resonating all three: the load, the capacitor, and the inductor. So this is, a different take on an RC or LC circuit. So let me load my presentation, and I'll go over the new numbers and data.
Nice.
All right. Can you guys see that? Okay, so previously we were working with the ABHA excitation circuit, Michael's modified Joule Thief. And specifically, we were working with this because it was showing promise in getting that high voltage output. But as it turns out, we can't really trust any of the numbers specifically for the current. As you'll find out in a minute, our multimeter is kind of unreliable. So we were using the Kaiweets. It's HT118E. And then there is HT118A, I believe. So it's like two variations of the same one with different milliamp. There's two fuses. There's a big fuse and a small fuse. So the small milliamp fuse is different on these, but they're essentially the same multimeter. Michael pointed out, to begin with, Michael pointed out for the Jewel Thief, I was not factoring in the duty cycle with the data. And this significantly reduces our output wattage when adjusted for the duty cycle. And this makes sense why we weren't really translating that into usable energy. And we were getting the 10 times voltage amplification on the output compared to the input. But we weren't seeing that translated in anything usable except for, you know, a neon lamp lighting up. So adjusted for the duty, say this 18 watts output compared to, you know, the 3.2 watt input, that's completely off. That's adjusted for the duty cycle. That's actually 1.5 watts output. That's a huge failure. Now, so since Michael brought it to my attention that I was measuring my current wrong, I decided to go back to the stereo amp board method, specifically because I wanted to go back to what Daniel Nunes was doing himself. You know, he claimed to only get, you know, extra energy gains with the stereo amp method. So we're going back to the basics here. And specifically, I was messing around with the capacitor. Now, as you'll see here, he recommends optional, a 0.15 microfarad capacitor in parallel with the load. And this I think is actually key if you want this thing to work properly. As I've kind of seen with my system, it really didn't get any interesting effects while I was sweeping the frequencies until I attached that capacitor and specifically had the neon lamps, like a high voltage load attached as well. So that's important as well. I did not have the neons attached, so there was no way of confirming any kind of extra gains coming out. So moving back to what Daniel said, he said he only got extra gains with the true AC sine wave. Now, this makes sense from a torsion theory. By effectively adding energy in both directions of the coil, you're creating two counter-rotating fields that create a 0 point on the coil's equatorial plane or neutral plane between the two electromagnetic fields. We know the two fields of study that have shown promise in OU are torsion physics and plasma physics. So what does this have to do with our waveform? By limiting the waveform to one direction in the coil, we can get interesting effects, but not OU, in my opinion, or from what I've observed at least. By introducing a pulse wave in both directions, simply does not produce the necessary requirements, specifically because it seems like the true AC sine wave has it carries the energy better with the duty cycle being at 50-50. And I don't know why this is, but that's just what I've observed. Okay, so let's move on to the actual numbers that we're getting now. Now that we have our multimeter hooked up correctly to measure the current, as well as using, I switched to a couple of multimeters I got from school. They're smaller, but they are very reliable. The one is picking up the voltage accurately, and the one that seems to be picking up the current pretty good. Although these need to be verified as well. So keep that in mind. We still need to verify these numbers. And specifically, I'm going to do that with an oscilloscope by measuring the current with an oscilloscope current probe in the future. But suffice it to say, all the data that we used above for the Jewel Thief has to be essentially thrown out or set aside due to the fact that more testing with different multimeters yielded different results, which were mixed. Now, we did not get any kind of consistency with our fancy twin meters, the Kaiweets here. I got these specifically because I thought they were going to be good for high frequency measurements. It turns out they're not really good at picking up the current. They get all wonky at high frequencies. So it wasn't until I switched back to my smaller meters that I got from school that we had something consistent. And specifically, we had a verification of voltage, and we are trying to verify the current as well. So I'm going to read the new numbers in a minute, but suffice it to say, the meters we were using were bad, so we switched them. Okay, so let's move on to okay, so I did test all the meters with the DC current, and they were all accurate. So it has to be the high frequencies that are making them wonky, right? So remember earlier we were reading about 14 volts max on the input, which I thought made sense. This small Drox board isn't really capable of putting out, well, I've seen it actually put out about 100 watts. Let me change that. Or 100 volts, sorry, 100 volts. But definitely not like 180, 200, or let alone 300 volts, right? That's just impossible for this little mini board. It is capable of putting out 80 watts per channel. So that's its limit. We finally picked up some numbers on the meter to verify the input that seemed to be matching the O-scope. So they were baffling before we kind of had this verification. Today's current reading also looked promising. I decided to disconnect the output current measurement and do one measurement at a time with the same meter, just to eliminate any impedance variables. And what we get is 43 milliamps going into the coil and 37 milliamps coming out with this voltage amplification. If these readings pan out under scrutiny, this development would be extremely phenomenal. Assuming everything is correct at this point, we get numbers exceeding 1,000% efficiency, which is, I don't think is accurate. But let's not jump to conclusions. We still have a lot to consider to obtain the true output of the coil, factoring in the startup power that's going into our mini board via the workbench power supply I have, and the waveform. So we have to consider a lot of variables for metrology, and I'm learning that. But the numbers do look promising, and it's acting the way it's supposed to when it's in resonance, which is key. So going down to, the chart numbers. Okay, so with no load attached, and keep an eye on the difference between no load, a load attached, and an extra load, which just means I have one DC fan, and then the extra load is 2 DC fans. Okay, this is very interesting. Okay, so with no load attached, we have 14 volts on the input, 200 milliamps reading on the input, 330 volts on the output, and only 7 milliamps on the output. So the input power turns out to be 2.8 watts, and the output gets a little bit of a loss at 2.31 watts. COP of 0.83, 83% efficient, not too shabby, but not what we're looking for. Okay. Moving down to adding a load, which is our DC fan. So I added a DC fan, 3 to 6 volt Arduino flower fan, 14 volts on the input. I didn't adjust the power level. I'm keeping it all at the max power level. The knob on the stereo amp is all the way up. And we're putting 17.9 volts into the stereo amp, which is the limit. It only needs 12 to 18 volts. So we're going to maximize that and seeing what kind of effects happen. Now, with the load attached, the input current drops slightly at 155 milliamps, and the output current rises slightly at 20 milliamps. Now, this brings us to an input power at face value of 2.17 watts and an output of 6.6 watts. And that's a COP of 3.04, or 304% efficient. Again, we need to verify this, but this is just the raw data here. Extra load. Now, this is the most interesting thing. The extra load attached. The input current drops significantly to 19 milliamps, while the output current still continues to increase. Right? So it's like it's tuning it in, and it's the load trying to get in harmony with the rest of the circuit. And as you do that, it seems like the demand is just or the supply is based on the demand, the load, and everything just kind of harmonizes. So let's go down to my theory. The resonance in the system is a balancing of energy between the inductor and capacitor, allowing the two to work together and not against one another. The key difference between the traditional LC circuits and the one I'm working with is that we are attempting to get the load in resonance with the two parts as well. As we tune our load to approximately 10 to 40 watts, we can see very noticeable efficiency gains. We must remember that the load acts as a capacitor itself. In my humble opinion, by getting all three components in harmony, we can maximize the efficiency of any system. And it kind of makes sense because at this level, I kind of reworked my theory. We're not violating Ohm's law. We're satisfying Ohm's law to 100% efficiency. What we're violating here is Lenz's law. And specifically, we're violating it because we're having the energy created by the back EMF created by the collapsing field. We're having that in resonance with the hot energy. And by doing that, it's in harmony. It's riding it like a wave, like a surfer would, instead of working against it. And this is just my theory. This is what I think is going on with the coil. I could be wrong, but I will show you how to tune the coil tonight. I am going to actually hand it back to Nathan as we get set up for our mini lab demonstration.
Yeah, that capacitor, the high frequency capacitor makes a big difference, Ben.
It does. It does. And also adding any capacitance after the fact as well. Like if you add a rectifier, you know, I had a rectifier hooked up to the DC fan with a couple of caps. So it, you know, the first time I tried it, I popped the cap at 50 volts and I'm like, well, there's got to be way more than 50 volts or at least 50 volts going into this cap. So it's all about getting the whole system in tune, right? You want to pick your load and what you're powering the system for just as carefully as the components in the system itself, if that makes any sense. That's what I'm learning, at least.
So when I use my Tesla coil, it's not much different than the stereo amp. So I'm still putting the sine wave in, and I'm just putting in a bit higher voltage in the beginning, but the whole amplification is still there the same. It just comes in at a higher value when it starts. But the resonance is the same. The channel A and B is the same. Being able to pull a second load on the second channel is absolutely amazing. I do that in mine as well. So, yeah, it's a total different story. Now that I see how it works, it matches up with yours just fine. So,
yeah, the pieces are falling into place. And with, you know, Gerald's theory incorporated, I think we're starting to build a picture of how this energy is going to be able to be utilized very, very effectively, you know?
What I like is the amount of the load that you're putting on there is pulling it to the system. It's like an attraction, isn't it?
Yeah, it's really cool. But that's exactly what we want to see. That's exactly how it's supposed to work. So we know, yeah, we need to verify the current. You know, we need to do more tests with an oscilloscope for sure, just to verify that. But at face value, it's doing what it's supposed to be doing, and that's what I'm satisfied with at the moment.
Yeah, you need a high voltage probe. So I have the same problem. It's right now. It pins my my oscilloscope at 190 volts. It won't let it go any higher. And then I try to put my meter on it, and it's too high for my meter to read. So I have to do the same thing, get a high voltage probe or something like that. I think Shawn said 10K resistors, putting a bunch of them together and then epoxying them turned out really well, made his own high voltage probe out of that. So maybe just buy one. You know what I mean?
Right. Hey, what's up, Gerald?
What's up, Gerald?
The sky's up. How's it going, guys?
Hey, how's it going, Gerald?
Yeah, I'm alive. I'm still coughing here and there, so kind of hear my voice. It's been a week. Man, I've sucked on so many lemons. I don't even want to tell you what's going on. You know what I'm saying? Anyway, good job, Ben. That's awesome. I've been watching in the background there.
Thank you. Yeah, we're getting some good results here. I'm really proud. I'm really excited. I'm really proud of myself.
I love the video. Oh, that was just great, man.
Yeah.
Right? Yeah. That's got to be on one of our spoof videos.
Yeah, or a highlight reel of because I was thinking about making a highlight reel for the year, you know?
Oh, that would be cool. Yeah.
Yeah. There's another clip that I want to get where all of us are dancing, where you playing my dancing, where I'm dancing, and then we all start dancing.
That's awesome. Dancing around the world, right? Yeah.
Yeah, we have fun on this show.
That's right.
Gotta eat, sleep, game,
repeat.
Nice.
Yeah.
I try to stream some video games every time I do the 3D print and chill, you know, have the camera on the 3D printer and play some video games.
I used to game a lot. I don't do it as much anymore because I'm one of those guys that tenses up in the neck, and since I have neck issues, it's kind of once in a blue moon thing. But I still do the old school. At least once a day, I'll be playing like 1942 or Galaga, or I got Pac-Man and Miss Pac-Man, and yeah. So I play those, but I don't get into my 3D like I used to. I'm telling you. I used to love it. I was bad. It was like 8-hour sessions with guys sometimes. I don't do that no more.
I like that 1942.
Yeah, it's a fun game.
So what have you been up to, Gerald?
About 5'8". I didn't think they piled it that high, but hey, I'm kidding. No, actually, you know what? I haven't done much this week. I've been doing a bunch of math and just resting. Right, I worked on my scooter. It's almost ready to show. I'm thinking maybe Friday I could show it off and spin the wheels and show charging and stuff like that, right?
I'm really excited about that.
What's that?
I'm really excited about that.
Yeah, and I drew up the schematic and everything, and we could go over that and how I set up the relay and the different battery banks. Yeah, it's you're gonna like it.
Is it safe to go over?
What's that?
Is the schematic safe to go over?
Yeah. Yeah. It's been child approved. Right? So it's good. My kid looked at it and went, "Oh, that's fun."
His schematics have been found in the adult section previously.
Just look at my ship design on that spoof. That was awesome, I'm telling you. The reactors. Anyway.
Hey, at least you can draw a circuit. I'm still working on it.
Yeah, just not freehand and out of brain, right? I got to be looking at my book, otherwise something might come up you don't want to see, or you want to see. I don't know. So where's Shawn?
Sean's not feeling too well. He's gonna sit this one out.
Too bad. Hope you're feeling better, Shawn.
Yep.
Yeah. Speedy recovery, brother.
Yep. Absolutely. Yeah, interesting events. Have you guys been watching what's going on and all around us and the whole YouTube free energy situation?
No,
Hey, real eyes, real lies, real lies.
So
There's lots of people releasing stuff right now, and I love it because I think that groups like us and the group that we came from or talked to, APEC, all those guys, because everybody's pushing, and we've been pushing hard. Nathan's discovery, what we're doing, Ben's getting there. Ben's there.
Ben's there.
It's there, right? Wait till you start extending and playing with ground lines and multiplication of your power while you're going to the ground line and tapping water. Anyway, we'll get into that later. But you're there. You're at the base now where you can build on it and start doing the extreme experiments that some would consider they are. I think they're just a evolution or a progression from the point that we were to the point where we're going.
Yeah.
Yeah.
We wouldn't do any big experiments, though, would we, Gerald?
No. No, we would never do that. I mean, like something crazy like building a coral castle or something. No,
with a giant coil.
Possible, right? I'm just saying, nobody can do that, right? Anyway.
Hey, I've been to Coral Castle. It's magical. It's absolutely magical. I'd love to go back. I recommend if anybody's in the area, go visit it. It's like $5 or $10. It's awesome. It's
geometrically genius.
And you could just get inside Edward Lee Scanlon's head. When you're in that space, you're like, this guy was, he was quite brilliant, but he was kind of isolated,
But he was missing. At the Coral Castle and all of his tools, there's missing pieces.
Oh, yeah. You can tell.
Coral Castle, if you want a good idea on how Coral Castle worked, go look up a YouTuber by the name of Vinny St. Vincent. His name is Roy. He's awesome. He built the core or part of the core to what Ed Leeds Scallon was doing with the Coral Castle. It has to do with the U, the TPU, when you lock it and then lock the current in.
Yeah, they even tell you they removed the magnet from, he had this little generator. They even tell you in the tour they removed the magnet. You know, why would you remove
more than that? Did you hear about the divers that went into the underground cave system that he tapped through water dowsing?
No, I haven't heard about that.
There were divers that went into the cave and let's say they retrieved something. Okay. So will Coral Castle still work the way it used to? I don't know.
Probably not.
Yeah. There's factors involved in this. Remember, what Nathan did with the ground line is a big part, but it's a part to what we're talking about and where we're going to.
Yeah. Well, he had a well over there. He could tap as far down as he wanted to.
He created the well. He actually dug himself stairs and a hole that went down to this underground cavern system that had an underground river, an underground flowing river.
Oh, nice.
Interesting, huh? And on the coast of Florida, and here's another key part that most people don't consider. He was on the tip. Oh, maybe I shouldn't say. I'm going to just say it. He was on the tip of the Bermuda Triangle.
Ooh.
He was on the tip of the Bermuda Triangle. I'm just going to say that much for now. We'll get into it later.
Oh, that's interesting.
Key point. It's a key point. Anyway.
All right. We're going to set up, Gerald. We're going to do your presentation. We're going to go through it. And then Ben's got a demonstration for later.
Awesome. Yeah. I'll do the best I can. I got a bit of brain fog, but I think I'm okay. So
we'll work with you, Gerald. You'll be fine. We have faith in you.
Awesome.
I'll play it. You guys let me know when to pause it, and we'll talk about it as we go.
Awesome.
So, let me grab it real quick.
I don't know if you want to just go through it slow like that. It's entirely up to you. You guys are going to have to kind of pull questions out of me. Like I said, got a bit of a brain fog. So.
Well, I'm just throwing it out there in case Ben has a question or I do, or you want to put something in perspective right there.
Right. So what was your idea, to run through it and then we break it down, or just to break it down as we go?
Just interrupt me when you want to, and we'll pause it and we'll talk about it.
Oh, kind of like I'm doing now, interrupting you.
Yeah, absolutely.
Sorry, dude. I'll shut up now.
In the scientific community and the physics community, fellow YouTubers, and everyone out there. Today I'm going to present to you the work that I've been doing for the last 14 years. It's going to have to be a 3-part series because there's just so much to this. In order to explain it, it's going to take a bit. So the first part and second part are going to be in physics terms. The second part will be math and a lot of it, or at least that's the intention. And the third part's going to be in layman's terms, sort of a garage talk, so to speak. I got to thank you all for spending the time to listen to me, and I appreciate your attention. So I'll get started. When delving into this avenue of research, I've discovered 7 instabilities that have been actively worked out of today's electrical systems design.
That's ball lightning.
And through experimentation, and I mean a lot of experimentation, it's been found to be accumulative in nature.
The ball lightning, right, Joe?
Yeah, that's ball lightning. It's not the whole glass turning purple or the shade. It's actually a ball that floats in between the 2 neon bars inside that glass tube. Now, what you're seeing there, it's kind of a crappy camera because it was my first camera, and I should have listened to Jeremiah Pop. Shout out, by the way. He took a welding glass and had put it in front of his camera, and you could see it better. He had a totally different means of doing it than mine. He had to use a microwave transformer, I think. But yeah, that's basically what ball lightning would look like.
So you had the green glass instead of the blue glass?
Yeah. Oh no, sorry, it was a blue glass. I apologize. Thank you for correcting me. And that blue glass showed the whole sphere, and it was perfect.
Wow.
Yeah. See, if I use, go ahead.
I was just gonna say, for anybody who's not aware, anytime you see a red neon on one of our setups going pink like this or magenta, that's what you're seeing.
You're getting, see, when it changes into pink and magenta, you're getting into that pressure inside that gas bubble that's going to allow it to form, right? But if you don't have ball lightning or control it in your system, it won't show up in your neon. You may get the shades because you're at a higher voltage and a higher pressure, but the ball that forms inside that tube comes from a different place in the system and flows through the system and collects there, because gas, well,
See, that makes sense.
Least resistance, right?
That makes sense because I'm in resonance with our stereo amp and I don't see it. You know, it's how
I think you can get there. I just don't think you're there yet.
Yeah. So I'm seeing the evidence that it's possible, I think. And what I see differently between my system and yours is bright pink and it stays bright pink. You know, it's like, bam. And mine's just kind of like flickers on a little bit.
In the near future, I'm going to show a video that I've been keeping close to the chest for a while. And let's just say it'll be very evident. Well, I'll just say it like this. It'll be very evident that I can control almost every aspect of it, and you can see it in perfection. And is that a bold claim? Yeah, I probably shouldn't go that far. It will be seen in the future, and then it will be experimented on and proved or debunked. That's kind of where my head's at. So go ahead.
I'm at the point where I'm just binging all of your content, Gerald. You know, constantly. I love your videos. I love what you've been doing.
Well, I made them short just for a purpose, right? Because people don't want to get into like hour-long videos on watching one experiment. I wanted to make a whole series of little experiments, and then at the end, put it all together in one big hour-long video, and explain through the theory exactly what I'm talking about, which is kind of going to be part 3, right? But right now, we're just breaking down part 1.
All right, let's get going.
Okay.
Yeah.
Take into consideration the flow patterns of sacred geometry and the flow of energy in and around a wire when putting to task the engineering of an electrical charge system in this manner. When doing so, certain conditions, effects, and instabilities begin to occur.
Pause for a sec.
These instabilities, they're in an electrical engineer's.
Okay, so in that last picture there, how that line went around the wire, and it showed just the quarter and the second quarter, or partial of the second quarter. Yeah, maybe go back a little there.
This one or this one?
Yeah. Start from there. Yeah, where it drew the line, and then it showed the point, and then it came over and it locked.
And around a wire when putting to task the engineering of an electrical charge system in this manner.
And
when doing so, certain conditions, effects, and instabilities begin to occur.
This part that you're seeing is very significant in the way that I lined up the wires and how the angular momentum is created in the system. Because that is the part that each copper line touches as they're intercrossing. Okay? So keep that in mind.
Oh, very cool.
These instabilities, they're in an electrical engineer's toolbox, but they're discarded. They're grounded out or even frowned upon. All that being said, for the moment, let's consider the model of charged particles. Every single electron emanates its own electric field, and all other electrons are acted upon by the electric field that are in near proximity. resulting in a kinetic motion or a vibration in forward movement. As Richard Feynman called it, the Zitterbuergung phenomenon. And as the motion of one electron adds to the next, an inertial action is produced, resulting in a wave-like development, similar to the wake field of energy and reverberation. If we now apply that same line of thought in the design of geometrical wave patterns created by sacred geometry in motion, a picture begins to form. This picture, it's a rectifying a disorganized movement, taking random motions and changing them into directed coherent motion of macroscopic material, or perhaps metamaterial. Maybe even what some have termed a coupling device with the energy that permeates our environment. These instabilities or multiplied effects, they produce a form of constructive interference.
Okay, let's stop right there for a second. So I've looked at those shapes, and depending on which shape you look at and which angle you look at, it changes the actual pattern of it. You're on mute.
You're right. But if you have a system that has multiple constructive interference patterns within it, you'll still produce this main interference pattern on the outside because of the way that they interact. You're not in this system because of the way that it's woven, because it's 180 degree out of phase. The fields cancel out each other longitudinally to a point, and they come out like a flat plate, and they're polarized. So the only part that comes out of the outside of the coil is this interference pattern that you're seeing when I pulse it in a certain wiring configuration, because there's 5. Okay, so this is like the main constructive interference pattern that comes out that I collect on my pickup coils that allows me to control temperature around the system itself. Does that make sense?
Yeah, it makes perfect sense, actually.
Okay. Was there any other question about this part?
No, I was picking up the same thing in mine. I was just wanting to confirm it, but yeah, you got it.
Okay, so now there's 2 waves in here creating a third wave, and you can see it up the center of that constructive wave pattern. The first wave would be your voltage, and your other wave would be your magnetic current or your backflow, your back electromotive force, your there's another term for it, brain fog, sorry. But basically when you're running power through a line and it heats up because of that current that you're throwing through it, that's a back electromotive force. And because of the way that the coils are wrapped, it collects that and sends it out in a pattern, because the fields that are created in each of that winding configuration make that pattern and split the current and the voltage and create that third pattern out the center. And that's how I collect on those pickup coils. There's 12 separate points on the outside. And when that pattern, the third pattern comes out, it actually comes out as a sphere, a microsphere. Okay. Bob Grinder just came out with a paper. He said he wrote it in a half hour on the train. It complements this work 100%.
Very cool. All right.
As a result to these 7 different processes that are involved, such as the skin effect, which produces the proximity effect, building a parasitic capacitance between the wires, creating a dichotron instability that coupled with the 180-degree out of phase geometry, creates kinetic inductance, which results in a frowned upon issue being the Miller effect. So I'll attempt to unpack this a little for everybody. While using sacred geometry in electrical engineering, the vortex coils of closely wound wire, one would think that group theory and Lie groups comes into play. But they unintentionally become a result or a product of the system as a whole, rather than a goal that was set out to be achieved. I hope to explain part of the physics to multiple effects or instabilities incorporated into a design with fractal components in a symmetrical pattern. I had to take into consideration the electromotive force in an inductor as alternate current flows through it. I also had to contemplate the resistive heat accumulated in such a system, as well as the back electromotive force created when current is flowing in the primary, which brought me to needing a way of direct conversion of heat to electrical energy in an electrical transformer. That said, after coming to a series of geometries to be experimented with and testing commenced, while working with high frequency pulsing, I had to keep in mind the skin effect and the fact that a wire could be thought of as a 3D cylinder, and the resistance of the wire concentrates the eddy currents flowing through a thin skin rather than the cross-sectional part of the wire itself. And this, coupled with the inductance, slows the current, creating heat in the process of these coils that are so closely wound together. At this time...
Okay, Gerald, we have a question here for you. What is the Miller effect?
Oh yeah, okay. The Miller effect it's an increase in capacitance between the input and the output of the whole circuit itself. So because of the way that the system works, there's an input capacitance that builds up within the whole system dynamically. It's not like power just runs through the coil. We all know it runs through the circuit, but because of the way that this power is created, it flows a little differently. The field actually expands and it creates a spherical sphere around the whole room. And because of that, it puts capacitance within the circuit itself, and it's an excess capacitance. It's more than what you would normally put in if you were pulsing it. It forms. That's the wrong term. I'm having a bit of a brain fog on explaining how it's formed, but it's basically the capacitance between the input and output of the whole circuit itself.
This is not the effect where it pulls in energy from the outside area, right?
Well, see, now that's the thing. That's why it's part of it. Because the whole system pulls energy in from the outside, and not the way most people think. It does it through temperature differential. It uses the heat and the cold. Because there's a charge imbalance in the center, there's a null zone. That's what I call it. But it's basically like a depletion region where there's no angular momentum, there's no kinetic flow, there's no nothing. There's absolutely nothing at that point. It's at the very center of the coil in that open core. And because of that, the separation in both those charges create a static, which builds up, and it goes throughout the whole system. Did that answer the question?
Yes.
Okay.
All right.
I had to contend with the Boltzmann equation for the fact that it has been achieved through experimentation, a temperature oscillator with low parasitics, giving it a self-tuning cycle with an electric field that is synchronized with the temperature signal. By changing the temperature while measuring the current, over the temperature ranges and frequencies. Let me say that again. By changing the temperature while measuring the current over the temperature ranges and frequencies that are relevant for the application with sharp and repetitive changes, it allows for the increase in the ability to control temperature. I'll repeat that one more time. It allows for the increase in the ability to control temperature.
You want to go over that
while
a bit?
decrease in the ability to cycle, requiring a perfect isolation for any given input of any thermal waveform.
Okay, Joe. That's got to be explained a little more. Go ahead.
Yeah, that's the control of heat. See, this system is pulsed so fast, and because I capture the back EMF instantaneously on one pulse, I'm constantly collecting it, never allowing current to build up, never allowing heat to build up, because of course, current against voltage, right, when you're running through your line, creates heat, right? It's that resistive factor, the impedance. Well, I don't get impedance because the system, the way it's wired, it's 180 degree out of phase right from the first pulse. And it's a mirrored image of the first coil of the primary, which puts it in resonance the second I start pulsing it. And because I pulse it very, very fast, like my rise time is insane, and so is the fall time, it never allows heat to cycle into the system. It's pulsing so fast, I'm grabbing that heat, turning it into voltage, and I can put it anywhere I want in the system, splitting the heat from the cold through pyroelectricity, which is basically like turning heat into voltage and making it useful, right? Rather than exhausting the heat or trying to ground it out, I capture it through the back EMF, move it around. I could put it in the coils on the outside, one coil on the outside. I could put it in the 3 coils in the middle, or I can put it in my circuit, or I could dump it into the ground because of the way that the system oscillates, and it oscillates very, very fast. Heat can't even build up. The cycle is stopped before it finishes. That's why entropy in that system can't continue either, because entropy is directly connected to heat, connected to your back EMF, all that. So does that answer your question?
Yeah. So do you set your load based on that in order to pull it out faster, or is it set by the transistor itself? Or is it set by the coil?
It depends on what I'm trying to do at the time or what I'm using the system for. So I could use the load to tune the system and put my heat in the load, or I can use the load to pull the cold energy into the system and move the heat to the outer coils, pulling the excess into energy itself and use it somewhere else while running the load. So the load is kind of like turning up the power supply, and the heat's coming into the system. I'm taking the heat, putting it where I want, changing it into voltage, and dumping it somewhere else. Basically building a big pot of energy, taking a cup out, and that's it. And continuing to take that cup out all day long, never worrying about that big pot that's full, because I'm filling it up little bits by little bits all day long.
So you're setting your frequency generator based on your load that goes into the resistance of the coil. And as soon as you put all 3 of those factors in place, you can get this thing running smooth.
Yep. And there's fine tuning factors as well. That's why I said I can tune it to the load. I could tune it to the heat. I could tune it to, depending on what I want to do with the system itself. In other words, what's that?
Oh, sorry. Is your pickup coils putting any kind of frequency back EMF into your coils themselves as they resonate?
It can, yep. Absolutely. But it doesn't always. Normally, I have the system set up so that the coils are pickups, and I distribute the heat to them, turn it into voltage, and I'll dump it into batteries. I could charge 12 batteries all at once from one input.
Nice. I'm just getting there.
I know, and you're getting there a different way, which is freaking incredible, man. I'm telling you, that's because everybody can build a Tesla coil, and no offense to everybody out there, not everybody can build this system. Although we are going to get it into your hands, we're going to get it into physicists' hands, we're going to get it out there, and people are going to build it, replicate it, and then they won't be able to deny it, or maybe they'll debunk me. We'll see, right?
Hey, yeah, we put you up to the challenge. Debunk us, you know?
I like
build it yourself.
Yeah, exactly. I like it when you try and debunk me. I love it.
Well,
man.
hold on. You have to offer one caveat to that. You have to let you come in there and tune it and show them how it runs, and not them just picking things out of the air.
Absolutely. So, you build it, I'll help you tune it, and then you can take it from there and start playing.
Well, Gerald, not only that,
if you build it, they will come.
Yeah, but you have to have a series of tests that you run it through as like programming for that human head, not for the coil, but for their mind to get them wrapped around it. No, I understand.
But that's the manual. There's specific experiments in here that can prove the ether, excess energy, what I call the cup, which is current unifying potentials, because there's multiple potentials in the system that make it work. There's not one, there's not 2 or 3 or 4, there's 7 minimum in order to make it's a dynamic system. You can't have one without the other. That's why in this theory, there's so many different things that occur. The Ehrenhoff-Bohm effect, surface wave tension. There's so much that's going on. And it depends on how you're pulsing it, where you're pulsing it, and what you're trying to do with the system itself.
Very cool.
Here's a manual. There's a manual with about, I think right now there's 80 experiments that from beginning to end would help you understand the system. And then you can take it and do whatever, right?
Very cool.
Making it an efficient thermodynamic cycle and allowing for the electrocaloric effect to be achieved. These concepts, they overlap each other to the accumulation of useful work. And due to the first 2 effects previously spoken of, parasitic capacitance is produced. And this unwanted capacitance that exists between the parts of an electrical component or circuit, due to the close proximity to each other, it becomes useful in kinetic inductance. And through the inertia created, the dichotron instability manifests, which really is a plasma created by 2 sheets of charge slipping past each other by 2 surface waves propagating in opposite directions, one over the other. Due to the Zitter-Buergung phenomenon, the wave-like motion that's created, combined with the 180-degree out-of-phase electromagnetic coil design, it allows kinetic inductance to be produced, giving way to the Miller effect, accounting for an increase in the equivalent input capacitance for an inverting voltage multiplier, an inverting voltage amplifier, due to the effect of the capacitance between the amplifier's input and output terminals.
Okay, Gerald, let's go back to this because that picture's just too good right there. This right here, I get a lot. This is one thing that'll destroy everything in your room. You want to go ahead and explain it?
That's asymmetrical capacitance that's built up in the inner open core of the system and the outer core of the system, which, how do I put that? Spins in the opposite direction as the inner core. So because of the way that the system is built, the fields that are created in the inner open core create a sphere. But it's not just like a sphere and it sits there. It's a pulsing sphere. So as it pulses, it builds capacitance in the area that it's sitting in. And it literally attaches to the environment that it's in. And then as the outer core of the coil itself starts to feel the inner core's capacitance, a spin is created. And then the whole room starts to build up. I've had my ears pop. If anyone's ever done mountain climbing, once you get past a certain height, you have to like blow your nose and your ears pop from the pressure. That happens when the system's on for a certain amount of time in a certain wiring configuration. It changes the atmospheric pressure due to asymmetrical capacitance.
Very cool.
So another part of that would be asymmetrical capacitance in this way is well, I'll say this. This system is the complete control of ball lightning.
So you not only have the ball lightning, you have the system to control it. You built every single thing that people just talk about. You already have it.
Yeah. Like I said, when this started, this journey for me, I wasn't looking for a theory to find something, and I wasn't trying to find something. I was trying to understand that which I rediscovered, that which was given to me. So it took me a while to figure out the proper language, because I won't lie to anyone. I got to the end of grade 11 and I got booted. And then my school records got wiped out. And I mean wiped out. There's nothing. So I'm a dummy according to papers, right? But at the same time, because I have this system and I've been mapping it for like 14 years, and I mean mapping it, I've done every test you could possibly imagine. And so I am where I am. Bob Grenier out of the Martin Fleischman Memorial Project the other day wrote a paper on the train, took him a half hour. I wrote this 2 months ago, tweaked it a couple weeks ago to add in certain temperature differential equations and things that were in the presentation. But yeah, it's Bob Grenier's work is just complementing what I have.
Now, just make sure we get that straight.
Yep.
Bob Green didn't come up with the first, that's for sure.
And Ken Shoulders and all those guys that came before him, whose work that he's going through, I'm standing on the shoulders of giants. I'm not saying I'm not, but I never studied any of their work. I never had any of their papers. I never even knew their names before Bob Grenier and the Martin Fleischman Memorial Project. This I had 14 years ago. And I show it on one of my videos when I'm very, it looks like I'm young. Like I have brown hair and I'm wearing a black shirt. Yeah, like that's my very first video. And that room that you see in that video, there were some very specific experiments done in that house that were so incredible. I had people sign affidavits over. So that video, that's a unique room. We'll say that.
Nice. All right, go back to just a little bit.
Higher. Sorry. An inverting voltage amplifier, due to the effect of the capacitance between the amplifier's input and output terminals. If we now consider the electromotive force or the electromagnetic force, potential voltage, when taken from a linear movement to an orbital flow, it becomes conical in its geometry. And by its very movement, it increases its velocity through compression, which in turn increases its mass due to field decompression through the quest for equilibrium. By using vector spin in the search for the path of least resistance, angular momentum has been observed. Now, at this point, you might be asking yourself, what about Lenz's law? You would not be wrong. Although we have to take into consideration the eddy currents that make up the electromotive force is negated by the use of the secondary winding of the coil system. In this system, the secondary winding was created as a 180 degrees out of phase mirrored image. I'll repeat that. In this system, the secondary winding was created as a 180 degree out of phase mirrored image in order to negate the resistance and capture the currents of the primary, giving way to energy flowing without impedance, bordering on superconductivity.
All right, Gerald, we'll stop right there for a second. Okay.
right.
You're negating Lenz's law by the 180 degree out of phase turn.
Yep.
Okay. Now we saw Mike defeat Lenz's law through cold energy. So can you explain the difference in the two?
To explain, I'm not going to go into too much of Mike's system because Mike loves explaining it. He does a good job of it. Other than he's not using current, he's using voltage and spin and creating current by capturing the voltage and spin through the voltage differences between the beginning and the ground. Does that make sense?
Yes.
And the way that I'm doing it is through those different instabilities that I was talking about. The skin effect, the dichotron instability, the Miller effect. There's a few of them in there, right? They all add to each other. And that's how I negate the Lenz's law, as well as the 180 degree out of phase. It's not just the 180 degree out of phase, but it's the mirrored image. And it's the way that the system is woven and overlaps, because in between the lines creates plasma. And then there's ether. And then there's plasma again. And then there's another copper line. And when they intercross, they create angular momentum, which is spin. I say spin for people's understanding. The physicists out there, they giggle when I say it. I don't care. So angular momentum is basically the spin, okay? And there's little tiny microspheres that are created in between each cross-sectional part of each line of copper in this system. And this system has 750 feet woven one way and 750 feet the other way. So you could just imagine in between each line, there's 144 to 288 different microspheres. And how many lines are there in that 750 feet? The math is, I'm still working on it. And I know I'll get it wrong, and it'll probably be worked on by those that are out there, corrected. I'm going to ask our mathematician of the group, right? And I appreciate it if you looked it over as well, Nathan. Like I said, when it comes to math, I trudge through it. I can do it, but I trudge through it, right? I'm not a mathematician by any means. I did want to clarify one comment, and I would normally agree with this comment, but I want to clarify something. At best, this is independent discovery. Let's be honest. So I will be honest, 100% honest. Is it independent discovery? Perhaps. Except that it was given to me through a series of visions and dreams, and I brought from what was in the dreams to reality. So is it an independent discovery, or is it something that was given to me, not just me? I'm no special. I'm just a guy in a basement playing with some tech. But was it given to me to give to everyone else? I don't know. Maybe Bob's doing the same thing for different reasons or same reasons. All the power to him. The more people out there that understand this, that have it, that are getting it, the better this world might become.
He wrote a paper on coils specifically?
Well, no, he wrote a paper on the understanding of how ball lightning works in what he calls 1 torr, 2 torr, 3 torr coils, which is basically angular momentum that goes this way. angular momentum that goes this way, and it goes in a circle.
Oh, okay.
The system that I work with is completely different. I literally can control ball lightning in ways that aren't really quite understood yet. We'll say it that way. And do I completely understand it? I'm still working on that. But at the same time, I've got it 99% down.
Do you think it could be, I forget the term, but there's like this microscopic theory of a plasmoid, like a plasmid or something? Do you think it could be like a quantum level, like plasmoid?
See, here's the thing. Those
at a very, very small scale.
The plasmoids that you're referring to come from Malcolm Bendall's theory. And although I kind of agree with part of the theory, what he's talking about is the toroid around the sphere. What he has not ball lightning, it's what goes around ball lightning. Do you understand what I mean by that?
So it's a part of the same phenomenon, but it's not like it's one aspect of the phenomenon.
I would say it's how do I put that without insulting the man? Because the man's done amazing work and he's making a system operable for the public. How much it does over Unity and what its purpose actually is, I'm not entirely up on yet. But the whole plasmoid thing, it's like the Rogan coil, right? And I'm not dissing on the Rogan coil, Ben. Don't take this the wrong way. It's a surface wave plasmoid system. It's nothing like what I'm doing. So the comparison would be like his system and the Rogan coil control the donut. And the system that I work with controls the sphere inside the donut that tunes the donut.
Oh, so what's that called? The counter image or the hourglass shape that is the abstract of the coil? Or
the hourglass shape is actually the flow of, I'll call it the flow of compressing fields that are like centripetally going in and out, right?
The two vortexes?
It comes in the bottom in a certain firing sequence. It comes in the top.
Yeah, I'm on day shift again.
Hey, look who it is.
And we're on day shift again.
Special guest, Mike K from Faraday.
Yeah, beat me up, Scotty.
So yeah, basically there's the way that the field's compressed, there's flow that goes into the top and comes out the bottom. And as it comes out the bottom, it spreads out, right? And that's the hourglass that you're talking about. But when that hourglass of flow comes and it meets the center point where that null zone or depletion region has been created, plus the electrostatic flow around the inside of that open core, that sphere where the two meet, that's where the sphere, it's like the point it hits,
like
creates,
the 0 point,
builds, and now you have asymmetrical capacity.
Yeah, it's like the 0 point of the system.
Yeah, that's why I said Malcolm Bendall, he has the surface wave of the toroid that is surrounded by the sphere itself, if you were to look at it in a plasmatic form.
That makes sense. Okay, you explained it now. Thank you.
Awesome. How's Mike doing?
Good. How are you guys?
Good.
Good.
Just going over the presentation thing.
Right on. Thanks.
Yeah, we got a little bit more to go. We're 6 more minutes.
Are you here for long, Mike?
Yeah, for a bit. I'll hang out.
All right. Okay, so go ahead, Nathan, and we'll finish.
This mechanism becomes the fundamental principle of design when attempting to achieve such constructive interference that brings resonance into action upon the very application of alternating current. When resonance occurs, the electromagnetic field created, as well as the secondary field from the secondary winding captured through induction, these two fields of inertia, they combine, producing a wave of superposition that produces a boundary layer leading to simultaneous effects, such as the Ehrenhoff-Bohm effect. The accumulated effects at this point, they allow for the observation of voltage difference, temperature differential, charge separation, and a form depletion region, partially facilitated by the capture of entropy, feeding the non-equilibrium state and never allowing entropy to succeed. Due to the inertial fields that created with all the accumulated potentials brings partial, I'll repeat that. Due to the inertial fields created with all the accumulated potentials brings partial or partial differential equations into motion. I don't know why I have such a hard time saying that. Partial differential equations into motion. In this system, the electromagnetic coil's field geometry produces voltage differences between the inner core and the boundary layer created outside of the outer rim of the coil, which exhibits the polarization of the surrounding media, coupled to the vacuum polarization of the inner open core. Now, due to the compression of the field's core, the confinement of the depletion region, or what some have coined the null zone in the center of the XYZ access point, it allows for the mechanism of charge separation to be controlled and manipulated in direct correlation in comparison to the position of the harvested potentials. Now, for certain wiring configurations, due to parametric oscillations within and around the depletion region, a conical motion of charge imbalances occur, continuing the inertial flow and bringing in an inrush of vacuum fluctuations, amplifying its potentials, giving rise to the dynamical Casimir effect. The charge imbalance created by the depletion region produces an electric field proportional to the square of the E field's intensity, which brings into question the second law of thermodynamics. The second law dictates that all systems naturally move to an equilibrium state, being a state towards maximum entropy. Therefore, a system that can change no more at all, it's defined to be at equilibrium. The geometrical wave patterns produced push the boundaries of the conservation of energy by allowing the potential voltage captured in the secondary winding of the bifilar coil to build capacitance, directing it to ground, creating a point of entropy, allowing for a second load to be used, bringing into order a mechanism of controlling part of the imbalance that sustains entropy's process to equilibrium. I'll repeat that because it's a mouthful. Bringing into order a mechanism of controlling part of the imbalance that sustains entropy's process to equilibrium. While this system and other configurations of winding in relation to the application of alternating current at high frequency in multiple experiments has been observed to show inertial mass reduction by reducing resistance to acceleration of motion, which actually brings to mind a quote from Nikola Tesla. He said, "The kinetic and potential of a body is a result of motion determined by the product of its mass and the square of its velocity." Through the employment of cascade and regeneration for the increase in power densities in systems created with sacred geometries, it allows for an orchestra of a dynamical electrical conversion of energy that produces an entire group of potential outcomes. Well, ladies and gentlemen, at this point, this brings me to part 2, where we'll delve into the geometrical magneto-hydrodynamical vortex coil and the production of inertial mass reduction, radiation remediation, and the gyroscopic flow of the inner coil of the system, as well as much, much more. I thank you for your time and your attention. Have a great day.
Okay, real quick, I want to hit one point before we bring everybody in to do the
Allows kinetic conductor.
that one shape right there. In this configuration, that's where you put your packets of I don't want to say this. This is where the information's stored. The packets of energy. This is coming straight from Bedini himself. This is where the information's stored. Is when you start seeing that, that's where it's stored. So it's ironic that he's dealing in cold energy and you're dealing in the same thing, back EMF, things like that. And you point out the packets. We know what that's writing. Can't say it, but we know what it's writing and we know what the packets are for.
Yep. 100%. It'll go to the Rumble video I'm going to release in the next little bit. I wanted to go over this first, and then I'm going to show some other stuff that goes towards the last comment that I put before the video ended.
Okay, go ahead. You want me to pull it up?
Yeah, the very last, it's a page there. No, not the red one, the white one at the end. Yeah. Gyroscopic flow of the open inner core. What do you think that does? It's a part of a control mechanism to ball lightning. It also goes to inertial mass reduction.
Hang on, didn't you say you were getting plasmoids in between the layers of the coil?
Mm-hmm. I got proof of it too. In fact, I can't use that one big coil that I show in a lot of the videos, the 750 foot one way or the other way, because I have proof inside of the acrylic that was surrounded. I had put it in acrylic. There's proof of EVOs all throughout it.
So
in fact, I have proof of one tunneling right through to the end.
When Bob talked about constructing them and then immediately dissipating them, you've already done that.
Oh yeah.
Yeah. That's already shown in your coil as an example inside your coil.
Yep. And I will show this in a future experiment, radiation remediation, because of the way that the system works. I was using Americium 241 out of a couple of smoke detectors, and I had my Geiger counter close to him, and I was collecting the signal, and I had the Americium in the center of the coil, pulsed at a very specific frequency, and my Geiger counter stopped picking it up. When I was done with the experiment, after a very specific time, and I shut the coil off and brought the Geiger counter close, there was no more signal. And I tested it for a week solid, no more signal. Take it for what it's worth. Take it with a grain of salt, a truck of salt, take a whole freaking stadium.
Okay,
Ken Shoulders wrote a paper on, transmutating radioactive material into non-radioactive isotopes.
Ken Shoulders is a genius. The issue with his system, and Hutchinson. But the issue with Shoulders' system is it's uncontrollable. It's raw.
Right. No, I'm just saying it's a something you could base your evidence off of. That it's building on his work pretty much.
Yeah, you could say that. Or, yeah. I won't say too much about that, but yeah, I'm standing on the shoulders of giants.
This is big though, because you know how easy if those results are accurate, then this is extremely easy to do. It's stupid.
Well,
it's easier than I think.
It's you have to look at how much voltage you're actually putting into the system. if you're putting in way less voltage into the system than Ken's shoulders was in Hutchison. So
Well, yeah, they're
obviously-
using high voltage and thousands of volts. I'm
Oh
using
yeah, that's right.
I'm
That's
using
right. He had
12
special
volts.
equipment.
12 volts to 48 max. I
Wow.
go over that and I have problems. I'll blow capacitors. My circuit will explode, which I have on
Yeah.
video too. Literally, the freaking transistor just
Wow.
boom! It was
Pops.
sounded like
Wow.
a shotgun. It was awesome.
That's crazy. I believe it, man. I've seen some crazy stuff too with this energy, man. You don't control it right, and it's disruptive.
it could go runaway on you.
Mm-hmm.
Good question. Did you test Geiger counter during afterwards with a known good rad source? You mean, was it what's the word I'm looking for?
Well, you were using the Aramicium, right?
Yeah, Mericium 241. Yeah.
Yeah,
Was it-
so,
Oh, there's a word. I can't think of it. My brain's just brain fart. Did I check it,
tritium or-
test it before I used it on the Mericium? Yes. And afterwards. Yes.
yeah, another one you could get a hold of in small keychains is tritium as well. That's also a good
Yeah, you know what? I'd love to order those little vials. To
yeah,
do
yeah.
tests
You can order them. Yeah,
because those would be, in my mind, for me, conclusive. None of this is going to be conclusive till you guys get it in your hands and start doing these tests. This is
yeah.
just,
As far as,
it's a reference for the public to understand it can be done, and that when you get it in your hands, you need to do these tests to find out. But do it with
yeah, because
safety. Like, safety is a big thing for me. I'm not just chucking shit in a room and going, let's do it.
yeah,
You know what I mean? I think this stuff through.
yeah. What I think is important too, like say like tritium, for example, it has a half-life of about 14 years. So if you're able to basically kill that field that normally under normal conditions would last 14 years, and you're killing it with your coil setup, that's pretty significant. That can pose a very helpful tool to say nuclear spills or
Yeah.
radiation breaches and stuff like that. Something that's useful, like it's going to do good.
And it takes the heat out of the area as well, right? So it does a few things. Like, let's say a very specific place in Japan, we won't say the name. One of these could be built to a specific size, brought there, turned on, and not only will it help clean, as the system was running and the signal was canceled, I was lighting up LED banks. Okay, so I'm pulling the energy out of it and making it null and void. So I'm changing it to its daughter product until I pull more energy out, and then it goes down again. More energy, it goes down again.
Wouldn't that be? Would it be fair to say you're transmutating the radiation into a cold energy, which is good? Benign.
Say that again. I didn't quite hear it.
Changing a radioactive isotope into a benign emission.
I believe through parametric oscillations and the resonance that's created in this system, that's exactly what's happening. Through a magnetic confinement position in the center of the open core, it holds it and it pulls the energy out of it, using it as a load and changing it to its daughter product and dropping it out the bottom.
The transmutation of energies.
Well, you could say that, but of energies, yeah, I would say that. Like, I don't think you could do it with regular, granite or stone or anything like that. But when it comes to high energy particles like Mericium and the other things we don't want to say, I believe so. 100%.
Yeah.
Has to be proven again. As I said, I've said this before, but now I'm finally at the stage where a lot of people are starting to understand how all this energy is beginning to work. Nathan's done major work on the ground systems. Now the rest of it, we're going to release, get into the public, and then we're going to get these things into your hands. And you're going to test it. doing. If you're talking about an RF blocker, I understand where you're going with that. But yes, and you can do with what Nathan's doing. It goes to that ground, the ground capacitance, and how the system works, right? Nathan's creating a bubble too, but he's creating it in a slightly different way. Think about the Tesla coil as being the center point, right? That's his 0 point. And then the field gets pushed out, tap the ground, and he's making his lights light up like 25 to 50 feet away. The one thing that hasn't been shown, if it happens, if it can, right? Will it go 50 feet in diameter from that Tesla coil? So it's this energy is bigger than what people expect, right? So it can be, yeah, I think you're right, Mike. I think it could be done, but it's a principle, right? All these systems, it's a basic principle.
So you're creating a force field, really, right?
You could say that. I haven't gotten into that part because that's going to be in part 2, right? Yeah. But when you're creating certain fields and they get to a certain energy level, you could say you're creating a force field. Yeah. I don't know about stopping bullets, though. I mean, yeah. But a field of force that, say, stops radio signals and other signals coming in or going out. Yeah, absolutely. Before I understood how the system was like how it works, I was having problems because I was blowing Wi-Fi routers.
There you go.
Yeah. Now I understand how it works. It doesn't happen anymore.
Joe, there was a question. Did you try any other type of coil?
Yeah, I have right now. I'm at 183 different types of coils. About 65% of those work in very, very similar ways. But 65% of those 183 all work. So, yeah.
I have another question for you.
Mm-hmm.
If, and just if, you got a chance to talk to Bob Grenier, would you do it?
Absolutely. I got no issues with Bob. Bob's great, man. He's smart. But at the same time, he's doing slightly different work than I'm doing. He's talking about the ball lightning and the transmutation of the metals that ball lightning hits. But the ball lightning that he studies is raw. It's not. Is it controllable? Perhaps, but the way that they're controlling it seems very chaotic in my mind. Maybe I'm wrong. If he corrects me, I'll definitely admit that. I'm not dissing on the guy, right? I'm just saying his work's different than mine. That's all.
Okay. Just be an interesting conversation based on what's going on.
Me and him have been on lives before. We've actually talked, but we were on with Bernie and Jeremy and a few others, and the conversation just gets crazy, right? So we couldn't really discuss what it was that I'm doing, what I have, the proof, all that. Like if I cut my coil in half and sent it to Bob Grenier, he would show exactly what's going on inside of it and go, yeah, okay. There's still one operating. Because there's ones in there that are still moving.
Yeah.
He stated it in his paper. They don't stop. They're alive. Well, yeah. Created at a certain frequency, they're inert. Do you know what I mean?
Hello, Lulu.
Lulu. Hello, Lulu. So I don't know if that answered all the questions to the presentation, but
yeah, whatever anybody else has got. Yeah, I was going through the questions, trying to get them as we went. Oh man,
I'm trying to come up with questions.
Yeah, sorry about that. Somebody had come in.
So, okay, based on all your research that you've done thus far, Gerald.
Yeah. Sorry, I was reading comments. Go ahead.
What direction do you want to go in? What's your end game? What's your goal?
Up. That's part. Yeah. In the end of it there, before radiation remediation, in part 2 and 3, we're going to talk about inertial mass reduction. But how much inertial mass reduction? Well, I've spoken about this in lives before. I've made that coil hop 6 feet with maybe 15 watts. See, that's the difference. There's a lot of different ways to making things go up, but how efficient you can make them go up is a big difference.
Okay, because I want to talk about this a little bit.
Yeah.
Because I contend that you do it with a very small amount of energy versus what other people think. And it depends on the type of energy you do it with. See, I always talk about it in the hot versus cold energy. So with hot energy, it would take millions of volts and it'd be worthless to try it.
You know what? If it was hot energy, I'll say this. Todd DiCiano's math, it's spot on. It would take 3 gigawatts. We're not using hot energy.
No.
Big difference.
Well, that's the thing. And I'm trying to make people understand that I did a video today talking about it's not a closed loop system at all. And I think that's the confusion here is they apply the physics of the closed loop system to it when it's not. And it won't behave as one either. Like if I put your pickup coil or my rod down the center of the Tesla coil, you've already immediately broken that system. It's already broken. You're not getting around it. That is not linked into it, wired to it, anything else. It's a pickup. So if you're using the pickup, you've already broken the system.
Yeah, because what you're doing, you're creating the loop through your circuit, your Tesla coil. You put your pole down the center, and as it's looping like this, you're capturing the secondary loop. You're capturing the back EMF through that copper or brass pole that you have going through the center, and you're making your loop through your line, your lights, and back to your Tesla coil. That's your cold energy. That's the second part. It's your back EMF.
Well, so you don't even have to loop the system if you didn't want to. You can seriously just push it straight out. And I push it right through my rodent coil, which gives me resonance in it, breaks the frequency. Then it goes as far as I need it to go. As long as I put the heat at the end of the load, I can pull that sucker far. And all it takes is one little bit to start it, and then it continues. And one trick that I found is it's like taking a pencil and wrapping your wire around it ever so often. It brings a little bit of heat to the system every time that you do that. So distances change based on your heat capture at that point. Now you can push the system a little further. It's like a pull, and then it stays in there, and then another pull, and it stays in there. But they also use that on the, oh my God, what is that? Testica experiment?
Oh, Testica. Yeah. Tesla in that town, the town that is run by that system.
Yes.
That system, that's an amazing system.
So check this out. I started doing experiments today. I took one Tesla coil and I put it down. I put a bigger Tesla coil number 2 right over top of it. And I'm trying to build out the system there, right? Because depending on where you are in the system and how far you pull this stuff, the amount of heat that builds up inside those when you cap them will change the actual amount of amps in it. So if I have a system that runs on potential, I can now change it into hot energy a little bit and get voltage and amperage out of it in order to convert right away.
Because your sphere is the room. The way that the Tesla coil works, going like this and like this, you're basically creating your temperature differential and controlling it through exactly how you're describing.
Go ahead. It's all in distance and how you cap the coils and how much heat you leave in them. And that's one of the biggest difference when you start capping things at a short distance on a coil. Then you start getting some fun stuff happening. And then you get another coil on the outside of that and it's capped. You know what I mean? As you build your system out, That's when you start to get to the real understanding of what they were trying to do there. It is not what you thought it was. It's in those two side little coils is where that whole machine is operated out of.
Yep. I wanted to address this. No offense or disrespect, but I think you don't need anything fancy. You're absolutely correct. You do not need anything fancy to tap this energy at all. To control ball lightning to a very specific fine point, I don't think you're going to do it with many systems. Could you do it with more than what I have? More than likely. I don't claim to have anything different than anyone else has. Nothing new under the sun. This stuff was done thousands of years ago. Just bringing out what I know. That's it. So no offense taken, man. None at all. So yeah,
Okay.
yeah.
Go ahead.
Well,
You
I was just gonna say, when it comes to the math, people might understand the system a little better, but again, I'm trudging through it. So part 2's coming. It's coming. That one's harder than I thought. I don't use AI. I never will, so I can't throw my stuff into AI and say come up with the math because it doesn't work like that.
I think the hardest thing in the beginning is learning what you're actually tapping into. You know? And as soon as you understand how to tap into it, then you can build a device around
And
that.
that's
But that doesn't always work that way. You have to
Good point.
experiment and then figure it out.
good point,
Right.
Mike. If you look at the physics community, they'll call it quantum physics or quantum vacuum fluctuations. If you look at the conspiracy theorist group, they're going to call it, ether or special energy or tachyons. If you look at the experimental community, we call it ether, we call it scalar. It's all the same thing. It's cold energy. It's the ability to literally use temperature, turning it into a voltage along with all the other things that come along with it. Because when you start messing with temperature, you get electrostatics involved, you get current involved, you get flow involved, which is angular momentum and spin. And it seems complicated, but it's basically the flow of energy, creating energy because of the very flow, and you're capturing that flow and letting the energy go, right? It's like Thomas Bearden used to say, create the dipole, don't touch it, let it run, and tap what comes off of it. Because what's a dipole?
Right.
It's basically a sphere that spins with a north and a south pole, creating static in its environment, and you're collecting the static. Okay, and that's just a simple way of explaining it. Those are not the right terms, but that's kind of how I'm putting it so that people...
But that's a good layman's way of explaining it, because a lot of people can't wrap their head around that. Especially when you listen to Tom Bearden, it can be a little bit of
well, Tom Bearden goes into phase conjugation, and what's phase conjugation? Okay, everybody talks about it. Not too many people understand what it actually is. Phase conjugation is 180-degree out of phase mirror image from your primary. That's it. That's what phase conjugation is. So people don't play with it because, of course, they don't understand it. If you don't understand something, it can be dangerous because you get into things that you shouldn't. Like you play with systems that are dangerous. But I'll clarify something for somebody. They had mentioned in the comment section about how they're not sure if in our consciousness we all have this map. Perhaps. But I didn't just get this in a dream or a series of dreams. YouTube doesn't like it when I say the name, but sorry, Nathan, I got to say it. I got it from Jesus Christ. Take it for what you will. Okay? I'm not saying it's mine. I'm saying that's where I got it. That's where it comes from. And that's why I understand it in its completion. because I've been mapping it, and I mean fully. So, just to clarify,
all the answers are in us. You just got to find it.
boom. No, wait, boom. I'm gonna get that right once, you know.
So
But
I
yeah,
have
it's
something.
all within us. You're absolutely correct. You just have to believe that it's in you, and you have to believe that you can get it out of you and bring it to a point of understanding to those around you, because it's going to help not just you, it's going to help everyone that surrounds you, and they're going to help everyone, and they're going to help everyone. And dude, you know how that works. If you tell two friends and they tell two friends and they tell two, everybody knows at the end, right?
Yeah. I wanted to answer a question here. When it comes to your Tesla coil, you have to understand it like this. When you start putting things down the center of it, you're going to explode your Tesla coil when you think that you want to overpower something. It's a matter of restraint.
Yeah.
You start putting pipes down there that are a half inch into a 2-inch pipe, you're going to blow up every circuit you got, and you'll never pull cold energy. If you get it to work, it'll pull hot energy. Why? Because you're overloading the center. You don't want to do that. It doesn't matter so much the mass, because it'll work itself out in the frequency. It's the size of the diameter. You don't want things more than over 1/8 of an inch. Get it maybe to 1/4 at the max in a hollow pipe. Other than that, don't go any further. You're at the borderline right there of hot energy and cold energy, and you don't want to be there. You're in the wrong place. So go thinner, colder it is. The thicker it is, the hotter it is. Now, if you understand that, balance it out the way you want to. But if you go stuffing, quartz down it or something else, you're going to fry the whole system. And I haven't met a Tesla coil that can accept that yet. They just won't do it.
Yeah.
So when you're messing with your Tesla coil, just know that the distance matters. Now, if we had an 8-inch Tesla coil and you gave me a piece of quartz to put in the center, I wouldn't have any problem with that, because now you have mass on the outside. You have more distance, right? So now we can accommodate that, but not with these little ones.
I want to build a Tesla coil that will match. I have a 1-foot-long quartz tube out of a quartz heater, and I would love to use that as the center for the rod of the Tesla coil, just to do the test. Or maybe see, you can pick one up at your local hardware. I'd just send you one, Nathan, and you could do the test. It'd be easier, right? Doing it in my coil, I already know what I'm going to see, but I'd love to see it out of a Tesla coil.
Well, I have right behind me, it's a little coil. It's about the same size. I bet you it's 28 gauge wire or something like that. Probably resonates right around 700 and something kilohertz. And that's the Tesla coil you have on your bench that I see all the time. Yeah. I can put 3 wraps around that sucker and get it to resonate real fast, and I can get it down to 20 hertz within seconds with one circuit. And what is it, 3 parts? Maybe 4 if you count the fan. And I can immediately get it running. Then I could seriously take that thing right there and then wrap a 1/4 inch copper tubing around it. And then I can play with hot and cold water through a pump and change the whole dynamic of your system, just like you're talking about. So, yeah, absolutely not a problem to get that running. And
you could take your Tesla coil, when you get it down to those hertz, get it down just a little bit more to 7.83, ground that sucker.
No.
To see what happens.
No, you don't want that test. You do not want that test. I'm sorry. There's tests that you don't do because you know what's going to happen. It's bad enough when you get close to it, but don't directly try to hit it.
And don't forget, you're living in California with a lot of
you're no kidding.
Right.
Thanks,
Gerald. No Warden Cliff from Cali. You're right. I take that back. Yeah. I take that back.
Can we say San Andreas fault line?
Yeah, but by the way, I got that out of a Slayer exciter circuit that I built. I can get 20 hertz with no problem.
Is that really solid one that doesn't?
The one that you wrote down? Yes.
Yeah. Yeah, those transistors are supposed to come in yesterday. I'm hoping they'll come in today or tomorrow.
kind of a special coil the way that thing's built, because it's literally so far out of resonance that it'll barely turn it on with the circuit, and you won't get as much energy you normally would. But once you start putting stuff down the center of that thing, magic starts happening.
So
It's
Nathan,
completely changes it.
Tesla talks about when you put a wire or whatever down the center of your Tesla coil, that's the source of where the impulse or the longitudinal wave emanates from. So would it be fair to say that's why you're getting such a huge power potential, because you're harnessing the longitudinal wave coming out of the center of the Tesla coil?
Yeah, it would probably be fair to say that.
Can I elaborate
Because
on that?
It's impulse energy.
Okay, so that wave you're talking about, that impulse energy, that's how you, what he's tapping into, that's how he's controlling the temperature. Right?
Yeah.
It's an oscillation. It's a
instantaneous
parametric oscillator, but not in the way that we're seeing it. It's oscillating with the ground and what he has in that circuit. It's a parametric oscillator.
Well,
It's a pump.
it's a pump, and it's instantaneous propagation.
Mm-hmm. With the speed of it, it feels that way.
Yeah, I would agree with you, except that if it's turned down, you can see the pulse in the bulb. So is it really instantaneous?
Well,
I guess it would be anyway, wouldn't it? No, you could be correct, Mike. You could be right. You could be right on that.
Yeah, because it's the impulse energy.
Well, you're not wrong.
Impulse energy.
But impulse energy is the cold energy, right?
Right.
And the Tesla coil, being the dipole, is the hot energy. So, and it's oscillating. Yeah. To think about that. Is it instantaneous or?
So one thing I have to do is I have to set up the piezo to pulse both sides of the rodent coil while this experiment's going on. So because it's 180 degrees out, because it's two phases in there, now we should see something special. If I pulse each side based on the phase I'm pulling it out at, now we should see some amplification. So what I'm getting right now, when I light up 5 Tesla coils, by the way, that's unheard of, okay, to do that. But how much more can I get them to go out? Can I get it 3 feet out at the furthest Tesla coil? If I pulse that with that piezo, I think I can, because it specifically acts on cold energy. It doesn't act so much to hot energy. That piezo only works to amplify the cold. That's why when I show my reading on my oscilloscope, everybody thinks you're drawing with crayon on there, but that's the actual oscilloscope doing that. And it only shows up in cold energy. So that pulse is extremely important. So I think I could get that sucker to push out even further than I ever thought.
I think so too. I
have something to show you, Nathan.
Go ahead.
I've got about about 500. I would say just over a pound of barium titanate sitting right in front of you.
Oh, I want some.
Know how much this is worth?
Yeah,
my buddy found.
I want some.
My partner found the supplier in China.
Wow.
He ordered a kilo of it. So just to put it in perspective, 10 grams, you can sell it for $45 US for 10 grams.
Okay, hold on. Say the name of it again.
Barium titanate, piezoelectric material.
Let's want to make sure we're clear on what it was.
Yeah, barium titanate. So very expensive. 10 grams will run you about almost $50.
Yeah, you can use that for multiple things, but I know what you're using it for.
I got.
I even know. Yeah, I know exactly the guy that. Man, I watched him right from his very first system that he put together right to the end until he passed away. Everything.
You have to clarify. I don't want to get pushback on this. Okay. Is it for your battery cell? Is that what it's for?
Yes.
Oh, okay. I
We
what I
are.
don't want
yeah,
is people thinking that we're talking about something else. Okay.
Oh,
No.
okay. Yeah.
Oh, that's okay.
Yeah.
Yeah.
I don't need YouTube coming after me. Okay.
Yeah, I
Sorry.
forgot about that factor. Sorry.
It's barium titanate, everybody. It's barium
Yeah.
titanate.
Okay.
Extremely expensive. So, yeah, my partner that I'm working on the cell technology, we found the supplier in China. So he ordered a kilo of it, and yeah, that little container there is probably worth about $1,000.
Easily. Yep.
Yeah, about $1,000 for that stuff. So, yeah, definitely experimenting. I was doing some metal anodizing today.
Well,
So, yeah, so I've been doing some anodizing of reactive metals,
nice.
and yeah, so that turned out really good. And yeah, so yeah, I have a lot to say Friday night on what's going on. So I got the big announcement.
Good.
I'm really excited about that, Mike.
Yeah.
When you
Yeah,
when you start wanting the test done between Nathan and I and Ben, I have a
Yeah.
feeling that cold energy getting put into your it's game changer.
yeah,
You know what I mean?
I think so too. Yeah, yeah.
Like
this
your
is some of the-
system itself should be a game changer in a way.
Yeah, we've kind of figured out where this could lead.
Yep.
I'll just kind of give a little hint. Stuff that T. Henry Moray was working.
Good.
Okay, that's where it's going to lead eventually.
Yep. Floyd Sweet type
Yeah.
deal.
No, well,
Slightly.
yeah, I would say a little bit what's Floyd Sweet, but more what T. Henry Moray. The power cell, if we do it right, we might actually be able to tap into radio frequencies and
Yep.
actually extract energy, say from a radio station or a cell phone tower. We might be actually able to merge with those forms of RF and actually funnel that power into the cell.
Yep.
So
I could see that.
yeah. So me and my partner have had some interesting conversations in the last couple of weeks about that, where it could lead to. I'll talk about it more on Friday.
No, I hear you. I don't want to pull anything out of you that we're Let's
Yeah.
build up
So
some,
it's interesting.
anticipation.
I'll be able to be a little bit more transparent on what we plan to do and where we want to go with this and stuff like that. So
Cool.
yeah.
Mike's prepping us for the season finale of November.
Yeah.
Yes.
Love it.
But,
no,
yeah,
I'm always
I-
excited about your updates.
Yeah, the guy I'm working with, I could just say, is he's very eccentric, extremely eccentric.
Nothing wrong with that.
Kind of difficult. Yeah, kind of difficult to deal with at times. He's very, very hyper in a way, like not in a bad way, but in a way that actually he's more detrimental to himself. You know what I mean? It kind of backfires
Oh, like
on
in
him.
my kind of way.
But yeah, he's been doing this. I would say at least 40 years, and he's known Bandini personally. He's known some of these guys personally, some of the big guys. Bandini's actually sat down with, had 2-hour conversations with him, and
Oh, that's
yeah,
cool.
so he got a lot of information out of him. Norman Wooten.
I'm jealous. I only got to ask Bedini one question.
Yeah, like I about 3 years ago, I got invited to the EV Gray news group board. That's where all these elite guys are. So that's where I met Norman Wooten, and he had an MRI device that he had that started with the transducers, the piezo's. And he went to Georgia Tech, he went to Stanford, he went to like 3 or 4 pretty big institutions. He's from Texas. And they said, yeah, this MRI device is putting out 40 over a COP. So him and his partner at the time, they went to try to file patent on this, and went back and forth between them and the lawyers, and they basically they kiboshed it right into the fucking ground. Sorry, excuse the speech, but
Yeah.
and they
Lawyers.
said it would be an act of God before they would actually release this. So yeah, and that happened in 1992 time. Around 92, 93 time frame.
Yeah, that was like the first wave of free energy or over unity from the legends, the old timers, right?
Yeah, like he also corresponded quite a bit with Edwin Gray, the guy who came up with the EV Gray motor. So Norman knows him. Knew him back when he was alive. He knew all these guys. So Norman's kind of an ace in this world, and thank God he's still alive. And every once in a while, I'll shoot him an email, and he says, "Yeah, Mike, play with the piezo's, man. That's where really a lot of magic is happening." So I've never forgotten that message that I got from him, and I showed him. I replicated his device, actually replicated it, and it does work. So he goes, "Excellent, Mike. Keep going with it." He always encouraged me to keep going with it. So,
because there's more.
Well, yeah, it just opens up avenues in different directions you can go.
Yeah.
Right? And one of them turned out to be my Renegade device. Lo and behold, I never knew that my Renegade device loves it. When you're triggering a coil and throwing a huge amount of inductive reactance right through a piezo, it just loves it. It just amplifies it.
I haven't even started playing with piezos yet. I have them. I just haven't had no time. I'll probably learn a lot, but I'll get there.
No, you're gonna find that it's gonna really refine the signal that you have.
Yeah, okay.
It's kind of like a solid state tuning fork.
Oh yeah, right. I know Nathan and I were talking about it before, and you had mentioned it before. I should try using it in my system. So it's something I definitely want to try. I want to see it tried in the Tesla coil as well.
Yeah, just try it. Like they don't have to be a very large one. You could get small, different size piezos. I would stick with the ceramic made ones, the barium titanate, which I have. Yeah, the small ones. Start with those and just get a feel for it first, right? Now, a lot of people think you hook them up in series in your circuit. Wrong. You hook it up in parallel. So what actually you're doing is you're shorting out your system. And that's exactly how it. And that's exactly how I run it in the Renegade. It actually is shorting it out.
Huh. That makes a lot more sense given the ultrasound device I have from Alexi. It's actually turning it off, not turning it on.
Right.
Oh, right. So it's already shorting it out.
Yeah.
Yeah.
Because it emits frequency, but it also receives frequency. So at some point you got to shut it off in one way.
That's right.
Was that the device you were shocking yourself with?
No.
Oh, that wasn't the one where you put it up to your beard?
No, that
no. That was something fun.
No, that was the plasma tube you had, right? The one that
the one that Shawn sent to me and got a great laugh out of it when I started shocking myself. He loved that thing.
I was laughing at that one. Yeah, that was funny. You're doing it on your face.
Oh yeah. Got me good.
Yeah.
Man,
this has been an awesome show.
Yeah, I think, really, Gerald, start playing with these piezos, man. You might be surprised.
I am. I'm gonna
hook it. Like I said before, hook it up in parallel with the coil.
So parallel with my secondary, basically.
Yeah.
Yeah.
Not in.
I have a feeling it's gonna throw things 180 degrees in phase then.
It could. Oh. You don't know until.
I've never had it go hot on me, if that's what you're worried about.
Oh no, I'm not worried about that. I'm not worried at all. In fact, I have a feeling I might actually start hearing the Doppler effect. You know what I mean?
Yeah, you start interfering with the airport radar.
That'd be bad, man. I don't want to go there.
Yeah, sir, it sounds like you got a woodpecker system flying out of your house.
Yeah. Yeah. I'm not Russian, okay?
Yeah.
Oh, wow. But that amplification is going to be big once we get that lined up in there. Even so, I need to replace my transistor in mine, but as soon as I do it, just to get it to start and to see the effects on the oscilloscope is going to be big. Because I think those lights are just going to start flashing in my garage. It's going to be awesome. So I tried it the other day, and that's when I blew out my hearing aid last time I used that device.
Yeah.
So I'm going to have to fix it and just replace the transistor and get it going again.
Yeah, and then it'll be your lights, your headphones, your computer, your everything will be like turning off and on. And
well, it's great for mapping because it's a controlled turn off. It turns it off when you want to do it. So it's good for see when peaks and valleys are, and then obviously the goal is like put it in like Mike did and put it part of your system. So
yeah, and use an AM radio, you'll be able to map it. You'll hear it. You hear that pitch, and I know you're good at pitches, so
yeah, I can hear those.
Yeah,
I don't hear many deep sounds and deep voices, stuff like that. I can't hear.
Yeah, it's certain hurts.
Yeah, my son was trying to talk to me last night. I had no idea what he said.
Does he talk really low?
Yeah, it's real deep voice, right? So I'm looking at him like with a blank face, going, nope. Nope. Don't understand.
Talk a little higher. Yeah, you gotta talk higher. You understand?
Yeah.
Just kidding.
Or if you don't want to talk to somebody, you could just pretend, yep, and they will have no idea.
I used to do that to my grandmother, and she would just laugh at me and tap me in the back of the head. Just somehow she knew I was doing it. I'd be like,
you knew. Yeah.
She'd be like,
she knew.
Oh, just be like laughing. Nicely, of course. Nice.
Oh, it's great.
Yeah, that's funny.
Yeah. Yeah, she had hearing aids. That's why. Like she had it bad.
Yeah, and also if you're playing with this stuff and you have a pacemaker, not a good idea.
Yeah, don't do that.
Nope.
I
actually
energy if you're no. Yeah, disclaimer.
That's one of the reasons why I didn't demo it to my grandfather. He's got a pacemaker.
Oh, yeah, not good.
I just show him videos when I can.
What?
Safety first.
Yes.
Mm-hmm.
So when we do the amplification, that's going to be like the big test, because to show the amount of power in a system, you need to show it at its peak. So not only are we getting the extra 20 from the ground, I'm getting a second ground, which I'm getting an extra 20%. Then I'm going to the center. Now I put it through the rodent coil, and now I'm going 180 degrees out with no question. Okay. Then I'm going to pulse the living daylights out of this thing. So I plan to move all the cars out of the driveways, put it right out there away from the house, and then just pulse it. Okay. And slam it down. And I just want to see, because what I want to show is the amount of power there. And once somebody sees the amount of power there, then they're going to understand why it's done that way. So I want my whole front yard to light up. I basically want a bulb in every corner on a 20-foot by 20-foot spike. And I want everything to light up. I want it to be like daylight. So I'm going to have to
like
push
the Griswold's Christmas. The Griswold's Christmas.
Yeah. When power goes out, they're all going to your house. Neighborhood power's out. Nathan's is glowing. It'll be funny.
Well, as long as they don't put it in 20 hertz or lower, I'll be all right.
Yeah.
It'll stop.
You're not wrong.
No EMPs, please. No EMPs.
Yeah, none of that stuff. What do you mean?
Oh
Yeah.
man.
This tech's coming along, definitely.
By the way, Ian said he put the wire down the Tesla coil and got some of the similar effects that I got. He did the pickup
Nice.
coils in his round coil, getting the effects that you got. And now he's able to compare both of them on his test bench, you know what I mean? One on one, and see exactly if they're the same energy. I think that's brilliant.
Although his round coil is
Nathan.
different from mine, though. But yeah,
Nathan,
that's
here's a thing to try, Nathan. Try to charge plastics. Try to get electrostatics on a plastic material like PVC or something like that, and then try
Why
to
is
light a
that
light
a
bulb
big
up
deal?
in PVC.
Charge it
If
in.
he's putting, yeah, like take the power coming out of the middle of the Tesla coil and tap it right onto a piece of PVC, right? And then try to light a light off the PVC. See if you can get the heavy side effect on the plastic itself and get a light to go.
Oh, yeah, I know what you're saying. Huh. Interesting. That's something. Something to think about. Kind of using it as like a pickup coil through electrostatics.
Well, yeah, because Bendini was able to light up LEDs off the battery after he charged it with the negative energy coming off the Bendini motor.
That makes sense.
And in the vacuum from this energy from the vacuum series.
When I'm doing tests with the coil and I'm using just 2 batteries, I can pick up. I don't know what that was. I can pick up a field with my EMF meter on the battery itself. So I think it's the
I got a
same.
thunderstorm here.
Oh, that's a big one.
Friggin' lightning and thundering out. It's
Okay.
like November.
So we'll have to put a stick with electrostatic material on one side and non-electric on the electrostatic on the other, and see if it picks up through it. Because just connecting a wire to the pipe won't get it done. It doesn't have any friction. There's no friction in it.
Oh, I see what you're saying. Yeah. So you'd have to stick something through the center of it to get that.
Some way of getting friction. That's it. To build up on there, I'd need to have something else. I have to have a catalyst. And
What about aluminum foil?
that might work.
Yeah. Kind of tap it that way, right? Interesting.
Yeah, you could do that.
Yeah.
Just an idea.
You should see what this stuff does. Maybe I shouldn't say that. Yeah, that's a future thing. I'm gonna leave that one to myself. It's coming. There's a few things. Actually, there's quite a few things I haven't released. Like I said, I'm at 183 coils now, and there's 2 coils I previously talked about. One I showed a preview of just how, or in the beginning that I was building it. That's gonna come out in the next week or 2. The sphere is gonna come out. I'll be displaying that, and then the alternator. And that's all I'll say about that. So there's others that I haven't talked about, but I'll talk about in future lives that will come out after that, because each coil I'm releasing is a progression for a specific cause that I'll be releasing.
Nice. Hey, Ben.
Yeah.
Did you have your experiment up and ready?
Yeah, but I was just gonna wait till tomorrow. Aren't we getting towards the end of the stream?
Yeah, that's what I was asking. If
Yeah, I'm done. I mean, I could talk forever. The mouth is huge, but I'm kidding.
do you want to wait till tomorrow, Ben, or do you want to do it now?
No, I'll wait till tomorrow so I have more time, because I'll do a proper stream. I'll come on and maybe around, let's say 1, 2 o'clock, something like that. Or actually, no, let's do 3 o'clock.
Right on.
1 o'clock, 2 o'clock, 3 o'clock, 4.
That's tomorrow, right? Tomorrow, 3 o'clock. You're gonna pop on live.
Yeah, 3 around 3. Hopefully, I'll try to get off work by then.
Okay. Well, if you do it on StreamYard, I'll pop in and say hi.
Awesome.
So
Yeah. Yeah, I'll do because I need to stream more on my channel and get my numbers up a little bit.
right on.
You
So,
could call
Mike-
it. Sorry, go ahead.
Okay, I was just going to ask Mike, what do you have going on this week? I know you're back on the Faraday Friday, the League of Extraordinary Inventors.
Love the title, by the
Friday
way.
night at 9. Yeah, actually, it was my buddy who came up with the name of it.
Love it. I'm gonna use it till I die, but it came from Mike Faraday. The research, yeah. I always get it wrong, you know.
Yeah, we'll talk about Friday. We'll talk about what's happening with the Power Cell project, and also I posted on Patreon the anodizing, how to anodize. So
Nice.
we can talk
Very
about
cool.
that. It's a lot easier than you might think. Just need a couple of household items, some deionized water, or what do you call it, distilled water, and you're good to go.
Distilled.
Power supply. Yep. So you can make one-way gates with those. There's a whole whack of stuff.
Wow. I gotta become part of your Patreon.
Exactly.
Yep.
Mhm.
Get all the good stuff.
That's it.
All right, Ben's going to do his demonstration tomorrow, guys. I'm going to pop in and say hi to him when he does it. Gerald, you coming on Friday?
I'll be on Friday. I'll bring something on. At the end, I'll probably show something. I don't know. I don't think I'll have my part 2 done though, and I won't release it on your channel. I'll release it on mine. But if you wanted it on the league, you're welcome to, Mike. It's entirely up to you. But yeah,
Well, it's your thing. So
well, I'll
tell me.
release it. But again, maybe we'll break it down. I can't get it done by this weekend, though, so I should just shut up. Sorry, everybody. I'm working on it.
There you go.
Yeah, Friday I'll have something to show.
Very good. All right, guys, that's all I have. I'll be on Friday. Be on tomorrow with Ben, and then we'll be over to see Mike later on that day on Friday. It's gonna be a fun time, man. Got a good weekend thing. Joe's gonna be out this weekend. He's still moving, so I think what I'm gonna do is just take the time and do the one wire energy on Saturday, and I'm just gonna take questions on it and answer them because I've done a lot of testing. And there's probably a ton of questions out there on it. So just give everybody a chance to ask the question and find out. And, it's sitting right behind me. I can fire it up at any time if we wanted to. So it's always neat to see when you start, turning off lights and putting everything in brightness out of there. So anyway, guys.
We want to thank everybody out there for the questions and for your time and your attention. You guys rock. Without you, we wouldn't be here. So
Yeah, you guys are awesome.
Yeah, thanks a lot, chat.
Right on. Thank you. Have a great night, everyone.
Yeah, have a
care.
good night.